Hi, good afternoon, guys. I'm just doing a quick video to go through some of the test review that I posted on Friday. You will have, quiz review that I posted on Friday. You will have the quiz tomorrow. It'll be posted during the again, I never remember whether it's asynchronous or synchronous day, but it'll be up tomorrow during the C day. It'll probably go up around like 9, 8. I'll try to put it up early, and it'll be due tomorrow. I don't know if I'm going to put a time cutoff on it besides midnight, but you'll see when I post it. Anyway, just to go through this. So for the directions, the first section here, it says to mark the given information on the diagram, then determine which triangle congruent shortcut, if any, allows you to make the congruent statement. So again, these are the four methods that we're using. It's going to be side, 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 angle, side, angle, side, angle, 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 side. Again, the ones that don't work are going to be the ones that you should not be looking for are going to be any AAAs. That's not going to prove triangles congruent. And any side angle. Again, if you flip it, it spells whatever, but that's not going to work either if you flipped it. Same thing. All right, so if we're looking at our picture, again, I picked a couple of these just to kind of also practice for the proofs because the diagrams for the proofs will not be marked. So it says BD is congruent to EG, so that's one given. The next thing says that angle B is congruent to angle E. So here's angle B, here's angle E, they're congruent. And then the last thing says that BC is congruent to EF. BC, EF. So hopefully at this point you guys can see that this is going to work. And it says why is triangle BCD congruent to EFG? It's going to be side, angle, side. So just from what was given here anyway, you should have been thinking if this was going to work, it was two sides and an angle, obviously, because we're given two sides and an angle. So keep that in mind that if it was going to work, you should have been thinking that combination anyway. For number 2, this one, we're going to mark the given again. We have BC and EF are congruent. We have CD and EG are congruent. I'm sorry, CD and FG. And then we have BD and EG are congruent. All right, there we go. And this is going to be side, side, side here. We have 3 pairs of congruent sides, so triangles are congruent by side, side, side. For number 3, we have angle C and angle F are congruent. We have angles D and G congruent. And then we have BC is congruent to EF. So we have 2 angles and a side. So because of that, we should be thinking one or the other. These are our 2 choices, ASA or angle, angle, side at this point. And if we look at the visual here, this is going to be an angle, angle, side setup because we have angle, angle, and the side is not in between. So that's going to be ASA. I'm sorry, AAS. The next one, number 4. For number 4, it says that BD is perpendicular to DC. So BD perpendicular to DC. What does perpendicular mean? It means they intersect at a 90-degree angle. So essentially, that's letting us know that we can put a right angle in here. It also tells us that EG is perpendicular to FG. So we can also put a right angle here. And then it tells us that angle C is congruent to angle F. So at this point, we have 2 angles. And 2 angles, it's not enough to prove anything congruent. So it's going to be not congruent. Next page is similar. Yeah, I guess we'll go ahead and do this. So for this one, we're given that RV is congruent to HL. Mark your picture. We're given that VX is congruent to LX. And we're given that angle V is congruent to angle L. So at this point, if we use solely what was given here, we could say SAS. But hopefully some of you guys are thinking outside of the given here, and you know that these 2 angles here would also be congruent. Let me put the 2 marks here. And the reason these would be congruent is because of vertical angles. So technically, you could have also had as an option, because I do have 1 or 2 questions on the quiz which are asking you, like, all the methods for proving the particular pair of triangles are congruent. So for this one, it could not only be SAS, it could also be ASA, angle, side, angle. And this could also be angle, angle, side. And the reason it could also be angle, angle, side is we could look at it as these two angles, like this, the other two blue angles here, and then this side. So it could also be angle, angle, side. So it could be any of those three methods. The only one it is not is SSS. All right, moving on to the next one. For number 6, this one, we have angle R and angle H. And we have XV is congruent to XL. So from the given, we don't have enough. But we do know that vertical angles are congruent. And again, that's something we can infer from a diagram. We do not need it to be given. So once we mark that, we have angle, angle, side. All right. I'm just going to skip around a little bit. I'm going to post, I'm going to post the full key, but I'm not going to go through like every single one of the same type of problems. It's the same. Let's look at something like number 10. Again, this is just kind of prepping you for the proofs as well. For 10, it says X is the midpoint of RH. So since X is the midpoint of RH, you would know that these were congruent. And that would be because definition midpoint. It also says X is the midpoint of VL. So that would give us that these are congruent. Excuse me, same reason, definition of midpoint. Then it tells us that VRV is congruent to HV. And, oops, let me put a third mark there. And that would make it SSS. Now, again, if that's all we needed, we're done. But in this case, we do have vertical angles, which are these here. And because these vertical angles are congruent, we also could have used SAS over here as an option. So moving on. Number 11, we can skip. All right, so let's go down to part 2. Part 2 has some short answers. Excuse me. It says which side is included between angles D and angle E. So here's angle D. Here's angle E. The side that's included between them would be this side here, DE. Oops, I'm putting angles on. Will be this side here, DE. It's the side between. Between means like in the middle, basically. The two angles. For B, it says which angles include BC, the side. So now we're talking about BC. So this is BC. And the angles that include, that means put it in the middle, are going to be angles B and angle C. So it's going to be angle B and angle C. I shouldn't say C for that, so I'm going to have to say A, C, B. And again, that's because C is a vertex of multiple angles. For the next section, it says tell which methods can be used to prove the triangle is congruent. I'm just going to go through these again. At this point, we've done numerous ones like this. Again, the first page of the quiz will be similar to this. The only thing that'll be different is that there will be the letters to write the congruency statements. But again, for this, all you need to do is write the method. For number 2, we're going to have angle, angle, side, because we have an extra angle here. For number 3, we're going to have angle, angle, side again, because we have the reflexive shared side. For number 4, we're going to have SAS, side, angle, side. For number 5, this one's going to be not congruent. We will get a third angle here, but again, 3 angles is not a congruency method. AAA is a no. For number 6, we will get an extra angle with the verticals, and therefore that'll be enough to give us angle, angle, side. For number 7, we will get the reflexive in the middle, so that'll give us ASA, angle, side, angle. They're all lined up. For number 8, we will get a side here, but again, there's no SSA or ASS, so this is going to be a no. And for number 9, this is going to be SSS. We have the reflexive shared side in the middle. All right, so for part 3, the directions say mark the diagram, then determine what additional information is necessary to prove the triangle is congruent. Now, what you'll notice is that it's giving you a specific method that's desired. So when you're determining the additional information that's necessary, you need to determine the additional information that's necessary for this specific method. So for this one, it's asking you for side, side, side. So I have AB, I have DE, I have BC, I have EF. So for side, 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 I would need a third side. And that third side would be AC and DF. So I would need AC is congruent to DF in order to prove this by side, side, side. For number 2, I need SAS. So I need my side, angle, side. And for number 2, I would have BC and EF. And I'm giving AC and DF. So for it to be side, angle, side, I already have the two sides. I'm missing the angle. Now, I need to know that by side, side, the angle has to be in between the sides. So my angle in particular is going to have to be angle C here and angle F here. So I would need angle C is congruent to angle F to have side, angle, side. For number 3, I need ASA. So for ASA, again, I'm going to mark my given. AC is congruent to DF. Angle A is congruent to angle D. And for ASA, I have the two angles and the side is in between. So for my side to be in between, the one I would need would be these two to be angle, side, angle, for them to be all lined up. So angle C is congruent to angle F is what I need. And number 4 is asking us for angle, angle, side. Sorry, I had to blow out the candle. So number 4 is asking us for angle, angle, side. So that's going to be angle A is congruent to angle D. That was a given. And angle B is congruent to angle E. So for it to be angle, angle, side, there's going to be 2 different possible options. I'm going to list them both. Either one will work. So I'll say or. You don't need both. But for angle, angle, side, it just can't be the side that's in between. So you don't want it to be like this side, the yellow side here, because that's ASA. That's not what we want. So what we need is for the other side to be the one. So we could say AC and DF. Or we could have the other pair and say, for instance, this one here, we could also have BC is congruent to EF. All right, let's keep it moving. All right, so these are just some multiple choice review questions. I don't know what I got going on with these B's up here. But it says what method below, which of the methods, it could be multiple, below, do not prove triangles are congruent. So if we look down below, it says select all that apply. So side, side, side is good. Angle, 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 is a no. Side, angle, side is good. Angle, side, angle is good. Angle, angle, side is good. SSA is not good. So those should be the 2 that do not prove triangles congruent. All right. These are very similar to the ones from the do now. I'm not going to bother to go through that. All right, let's look at 3. In the accompanying diagram of triangles BAT and FLU, angle B is congruent to angle F. BA is congruent to FL. And the question says, which statement is needed to prove the triangles are congruent? So let's choose a different color and see which one would be needed. So if I started with the first one, angle A is congruent to angle L. That would work. We would have, that's obviously our answer already. That would be our angle, side angle at that point. Let's just see why the other ones aren't the option. If I put AT is congruent to LU, I would have that SSA set up, which doesn't work. So that's not going to work. The next one would be angle A is congruent to angle U. And some of you might think that would work, but the reason this is not going to work is because this would be ASA and this would be angle side. So those would not be the same method. So therefore that would not work for C either. And then the parallel lines would be ridiculous. So the answer is A. Here's a few multiple choice. Again, I think you guys can handle those. Just want to go through things. All right. So I'll go through a few of the proofs here. So for number 1, it says given that they're right angles, angle ADB and CDB. So here's ADB, and that's a right angle. And it also says the CDB is a right angle. So we're going to have 2 right angles there. And it also says, statements, reasons, that angle A is congruent to angle C. So those are our 2 givens. Now, I'm not going to write them. I'm just going to put a dash in the given. But again, make sure you write the givens down. Now, we I think did this in 1 proof, maybe 2. But I told you that this is a necessary step when it comes to proofs, is that saying that angles are right is like me saying angles are obtuse. It's like me saying angles are acute. It's not enough to determine congruence. So you need to make an additional step here for step 2 and say that angle ADB is congruent to angle CDB, and that's because all right angles are congruent. Because again, a right angle is a classification. It's like me saying if they're right, they're acute. So alone, that does not indicate congruence. You need to state they're congruent. Then we already have 2 angles now at this point. So the givens are used. This is done. This is done. So now we're going to have to look at our visual and see if we can get anything from the picture. Again, the only 2 things you can assume from a diagram are reflexives, is the reflexive side and vertical angles. We do not have vertical angles, but we do have a reflexive side here. The reflexive side is right here, our BD. So we're going to say BD is congruent to BD. Reflexive. Property of congruence. And then for step 4, the reason the 2 triangles are congruent, again, copy the exact order that it's written in the statement. It's going to be because of angle side. The next one, number 2. Number 2. For number 2 here, it says given. Again, it's the same things that are happening over and over for our proofs, guys. I'm not going to throw anything different really out there. It'll be the same type of reasonings. This one tells us that AB is parallel to CD. So first of all, you're going to write our given. In addition to writing our given, you want to make sure you mark it on the picture. And it says that E is the midpoint of AC. So here's E. It's the midpoint of AC. So this one. So I'm going to use the midpoint first. Excuse me. Because E is the midpoint of AC, I know that AE is congruent to CE. The reason is definition of a midpoint. Number 3, I can use 2 things. I can use the vertical angles. And again, I told you guys that if you want, you can just put a number in place and you can just do it that way. But again, you can only do that if you label the picture with a number. So I'm going to say angle 1 is congruent to angle 2, and that's vertical angle theorem. Now, you can do this proof without that, and I'll explain that in a second, but I'm going to use that just to kind of mix up the reasons today. And then another reason, would be to say, I'm going to go with A and C. Angle A is congruent to angle C. And the reason for angle A being congruent to angle C is going to be because of the alternate interior angle theorem. Remember our alternate interior angles, if the lines are parallel, these are my AIAs and they're going to be congruent. So the reason I said I didn't have to necessarily use the vertical angles is because I could have also used this other pair of vertical angles. The other pair of alternate interior angles. If I use B and D, the other pair of alternate interior angles, excuse me, this could have been angle, side, etc. So it could have also worked a different way. But again, the route I went right now was using the verticals, and then I have angle, side, angle. So I'm going to go with, for 5, triangle ABE is congruent to triangle CDE by ASA. But again, another option could have been, I could have said angle A is congruent to angle C, AIA. I could have said angle B is congruent to angle D, AIA as well. And then I would have had the triangle by angle, side. So there's a few different choices. I could have picked B and D instead of A and C, and I would have also had angle, side. So there was a little bit of fluency there for what you want to do. All right, so let's see which one I should do. Okay, I'm trying to see which one of these next few I should do. I guess I'll go with the angle bisector one. So for number 3, it says CF bisects blah blah blah. So I'm gonna again write my given. First step in any proof, and I'm going to mark my picture. So I have CF bisects DFH. So here's DFH, and this bisects it. So that means that these are congruent. So I'm going to say here for 2, angle DFC is congruent to angle HFC. Definition, angle bisector, because an angle bisector splits an angle into 2 congruent parts. Number 3, I'm sorry, I didn't mark the other given. The other given were these angles over here. And then for number 3, I'm going to say that CF is congruent to CF, reflexive. Property of congruence. Sorry, I just realized it's time for me to go to my live extra help. So I'm trying to rush through this. DFC is congruent to HFC. And that's going to be because of angle, side, angle, ASA. All right. So again, I'll post the full answer key, but the video I'm just going to go through a little bit of everything. So at this point, I've touched a little bit of everything. Again, the quiz is tomorrow. There'll be a couple simple multiple choice type of questions. Again, the determining which type, basically the different problems that I've done here today. Have a great day. I will see you on Wednesday. And don't forget, your quiz will go up tomorrow morning at 8. Have a great day.